Good evening, all of you. Am I audible? Please mention in the chat whether the audio video is clear. Yes. So welcome all of you. Welcome back to the second lecture on permutation combination. Yesterday in the end of the class there was some technical issue that the video was not playing well. So yeah, actually to compensate for that, we are scheduling one more lecture tomorrow. So there will be third lecture. The final lecture for permutation combination will be tomorrow. So today we will be discussing PYQs of GATE on this topic, and then the remaining topics that you need to learn we will be discussing tomorrow. That means a continuation of yesterday's topic also will be covered in the tomorrow session. So that will be the last lecture on permutation combinations. So I think we can start today's session in 1 minute. By that time, please invite your friends, like this video, subscribe this channel, forward this link to more and more people. Let more people attend this free full-length course for GATE General Aptitude for the upcoming GATE exam. So those people who are new to my channel, this is a full-length course where we are discussing all the topics of GATE exam for GATE verbal ability and non-verbal ability. Verbal ability at 11 a.m. daily, a free class series is running in the Unacademy platform. I'm taking a free class series. If you want to get further updates of all my upcoming free classes and the previous free classes, you can check out my Telegram channel, Telegram group and WhatsApp group. In the description of this video also, you can get more details of all these free resources I am providing. And if you want more updates in my mobile application also, you can get free materials and free study materials, and you will get daily notification of the free live class I take in different platforms. So you can download it from Google Play Store. Christy's Classes is the name of the mobile application. And my details of the Unacademy free classes I take. Normally my free classes in Unacademy is at 11 a.m. So tomorrow 11 a.m. also, verbal ability, 20 questions of verbal ability we will be discussing. Priyanka, I will try to. So these are the details of the Unacademy free classes at 11 a.m. For CSIR-NET category, I teach in Unacademy platform. But in CSIR category also, I take classes for GATE as many pure science pure science CSIR-NET aspirants prepare for GATE also. But my classes are common for all GATE and all GATE aspirants, whether it is B.Tech aspirant or CSIR-NET aspirant. You will be able to follow these classes because general aptitude is common. This is a common syllabus for all GATE aspirants issued by IIT Kharagpur for GATE 2022. So I think we can start. Hope more people will be joining live in between. So make sure all your friends are invited to this session. If you haven't invited, please share the link to them right now. Let more people join this free course. So yesterday we discussed fundamental principle of counting and some applications of it and how that is connected to combination permutation. That is where the technical video issue was there. That I will discuss tomorrow. So today we will see some applications of these ideas we learned yesterday and the fundamental principle of counting mainly in the GATE previous year question papers. We will take different questions and understand this concept more elaborately. Yesterday I summarized what is NCR and when to use NCR is given here. So we will start with the questions and further learning we will have after discussing these questions. So please try this question one by one. GATE 2019 problem. All of you make a try. Any answers? Very good. Simarjeet, Yugen, Divyesh, Nikunj, Maya, Priyanka, Bhavana. Already got it right. Wonderful. So yes, option A, 6 is the answer. Why 6 is the answer? 5 different books PQRST are to be arranged on a shelf. The books R and S are to be arranged first and second respectively from the right side of the shelf. The number of different orders in which, this can be done, that is a question. So here, yeah, any question actually can be done by basic counting also, by permutation combination formula also, by fundamental principle of counting also. So the idea is, in a particular question which is faster, which is more effective, that you have to choose. Here basic fundamental principle of counting itself you can use, or basic counting also you can use. I will show you both the ways. Or if you want permutation combination way, that also we will discuss, so that you get the idea of how these are connected. So PQRST, there are 5 slots in this shelf, but 2 slots are already fixed. R to the right end, S to the second last position. Only 3 spots are remaining. Yesterday we discussed anagram problem, na? That means 3 position, 3 things to be arranged. 3 things to be arranged. So definitely 3 factorial ways are there. 6 ways are there. That is enough to understand. Otherwise, elaborately if you think, there are 3 books. P, Q and T are the 3 books. So P, Q and T are the 3 books. So here P, Q, T, any one of it can come. So there are 3 ways of filling this position. Now that book cannot be filled here, or that pick cannot be used anymore. So definitely 2 ways you can fill here and 1 way you can fill here. Fundamental principle of counting, if you use 3 into 2 into 1, 6 is the answer. Or as the numbers are small, if you list it out also, there is no problem. PQT is a possibility, PTQ is a possibility, QPT is a possibility, QTP is possible, TQP is possible, TPQ is also possible. But listing is not possible for bigger numbers. So this is a fundamental principle way of doing it. This is the counting way of doing it. And if you want to use permutation combination formula, which I haven't discussed much, because as I told, we need to connect the fundamental principle of counting with permutation, that we will discuss more tomorrow. Anyway, permutation combination way, if you want to do 3 positions, we need to select and arrange. If you need to select and arrange permutations, if you don't want to arrange, only combination. Here selecting and arranging is needed. So definitely you can use permutation. So if you do 3P3, that way also you can do this question. 3P3, because 3 things selected and 3 things arranged. So 3 positions, 3 things to be arranged. So 3P3. So that way also you can do 3P3 is 3 factorial by 3 minus 3 factorial, that is 0 factorial. That is 6 itself, because 0 factorial is 1. This third way of doing this question, don't worry about it now. Tomorrow we will discuss more about it. But what I am trying to say is, almost all the questions, there are 3 different ways of doing it. Basic counting is possible, but for bigger cases, basic counting is not practical. Fundamental principle of counting is possible, and also permutation or combination. Yeah, the same thing can be expressed in combination also, because every permutation can be expressed as combination, every combination can be expressed as permutation also. Again, that kind of things tomorrow we will discuss. Anyway, I'm sure that all of you have got 6 as the answer in whichever way. So as it is the first question, I was just connecting it with what we learned yesterday. Once you are clear about it, only use the most effective way or most fastest way of doing it. So let us discuss more these kinds of questions. So try this. This is a GATE 2011 problem. All of you make a try. GATE 2011 problem. And new students, you can subscribe the channel and hit the bell icon for getting updates of the upcoming classes. And so if you are watching this lecture, if you are getting benefit from this session, please like this video and share it with more and more people. So try this question, all of you. Some of you already got the answer. Wonderful. Different answers I can see in the chat box. Option A, option B, option C, option D. All 4 options I can see here. Okay, so let's start discussing. Today we are planning to cover almost 15 to 20 questions from different previous year question papers itself. Second. So in how many ways 3 scholarship can be awarded to 4 applicants when each applicant can receive any number of scholarships? So here you should clearly think from which perspective you should think. You should think from the scholarships perspective or the students perspective, because both are possible. These all are just common sense and basic understanding of fundamental principle of funding solves almost all the questions in this chapter. So in how many ways 3 scholarship can be awarded for 4 applicants? And what is the constraint? Each applicant can receive any number of scholarship. So each applicant can receive any number of scholarship means scholarship 1, scholarship 2, scholarship 3. From the scholarship perspective we will think. 3 scholarships है ना. So scholarship 1 का perspective में think करो. Scholarship 1 देने का कितना possibilities है? You can give it to the applicant number 1. You can give it to applicant number 2 also. You can give it to applicant number 3 also. So there are 3 ways to fill the first position. Sorry, how many applicants? 4 applicants. So there are 4 ways to fill that. Are you understanding? If 4 applicants are A, B, C, D, you can give the scholarship to A, you can give the scholarship to B, you can give the scholarship to C, and you can give the scholarship to D also. So 4 ways scholarship 1 can be given. Now scholarship 2, can this be given to the same applicant? Yeah, that is where your common sense should work. In the previous anagram problem or even in the previous question where you need to arrange the book, once you took a book and fixed somewhere, that book is not available anymore. But the applicants are still available, because an applicant can receive any number of scholarship, na? So an applicant getting all the 3 scholarship is also okay. 2 scholarship is okay. 1 scholarship is okay. 0 scholarship also is okay. So definitely scholarship 2 can be given to the same 4 applicants itself. Not 3 applicants, any one of the 4 applicants, A, B, C, D can receive. So that is again 4 itself. Similarly, scholarship 3 can be given to 4 people itself. 4 people means there are 4 ways to give scholarship 3. Now, one thing can be done in M ways, another thing in N ways, another thing in P ways, means total ways is 4 into 4 into 4, 64. Now, if the question was asking 5 applicants, 5 into 5 into 5, 5 cube will be the answer. 10 applicants, 10 cube would have been the answer. If there are 4 scholarship and 10 applicants, 10 raised to 4 would have been the answer. Don't by heart it like m raised to n. Understand the scenario and frame the logic there. Many people, what they try to do is they ask, for this question what formula, for that question what formula. That way of understanding, actually the problem is that will cripple us for questions that is higher logic. We cannot form our own logic out of it. We may still want a formula specific for that question. So in my opinion, that kind of a learning for GATE exam, especially for these kinds of chapter, is not possible or not effective. That is just a temporary fix. So that is why I will suggest try to get deeper into the meaning of the question and form your own logic. And basically what you need is fundamental principle of counting. Even permutation combination is just a special case of fundamental principle of counting. Did you all understood this? 64y. Those of you have got different answers, hope this is clear now. Why 64 is the answer. So that was a GATE 2011 problem. Let us see a question where numbers are involved. Numbers related questions also were asked in different GATE exams. This was asked in GATE 2019. 2021, many questions were asked, but most of them from this chapter was asked like seating arrangement itself, where permutation combination comes. That I will explain. Make a try on this question, all of you. Simarjit is asking if we think as applicant 81 is coming. No, you cannot think as applicant just like this, Simarjit. That is the difference. In the previous question, those of you are doubt. If you think from applicant's perspective, if A, B, C, D are the 4 applicants, applicant A cannot have, if applicant A get 3 scholarship, at the same time applicant B also cannot get 3 scholarship. That is the difference. Yeah, applicant A getting all the 3 scholarship is possible, but then applicant B will be getting 0 scholarship now. And applicant A getting 2 scholarship, then you have to think about the different permutation combination. That will be very complicated. That is why don't think from the perspective of applicant in the previous question. You cannot do so. Scholarship, because scholarships we are trying to fill that scholarship because the applicant number is flexible. Scholarship number is not. That's a difference. So hope that is clear. We will discuss more and more questions, then this concept will get more and more clear. Okay, some of you already got the answer right for this question. How many integers are there between 100 and 1000? All of whose digits are even. Even digits, you know, 0, 2, 4, 6 and 8 are the even digits. All of whose digits are even. Don't misunderstand the question. Question is not asking how many even numbers. Even numbers, only last digit is even is necessary. The other digits can be even or odd. But here all digits should be even. Unit place should be even, tens place should be even, hundredth place also should be even. So that is super easy now. Once you understood the question, it is super easy. Unit place कितने तरीके से fill कर सकता है? Unit place में 0 आ सकता है, 2 आ सकता है, 4 आ सकता है, 6 आ सकता है, 8 आ सकता है. So definitely there are 5 ways you can fill the unit place of the number, whichever number. So of this 3-digit number, there are 5 ways to fill. Tens place, what all can occur in tens place? Again, 0, 2, 4, 6, 8. Any one can be possible. There are 5 ways. Because question didn't say don't repeat the digits. You can't repeat the digits. So that means repetition of digits is possible. That means 2, 2, 2 is a valid example. 4, 4, 4 is a valid example. 8, 20, 28 is a valid example. That is why we don't have to reduce the number of digits. That is what I told. According to the scenario only you can form the equation or formula. Don't by heart a formula for each of the question. That is not practical. So 0, 2, 4, 6, 8, there are 5 ways. But remember, hundredths place you cannot fill in 5 ways. Even if it is even digit, 0 is not possible. 2, 4, 6, 8 only possible. Why? Because the number should be between 100 to 1000 only. Any number between 100 to 1000, the minimum 100th digit possible is 1 only, na? 110, 120. Like 24 is not allowed, right? Saying it is 0, 2, 4. Because question says we need between 100 to 1000 only, not 0 to 1000. If it is 0 to 1000, at least we have a chance to say a 2-digit number can be written as 0, 2, 4. There also there is an ambiguity. So to avoid that ambiguity, they have clearly defined 100 to 1000 only we need. So definitely hundredths place can only be filled in 4 ways. Either the digit 2 or the digit 4 or the digit 6 or the digit 8. Now again fundamental principle of counting multiplication rule. 4 ways you can fill the hundredths place, 5 ways tens place and 5 ways units place. So total number of ways is 4 into 5 into 5. 100 such numbers are possible. 100 such numbers means 102, 104, not 102, 202 onwards. All the digits should be even. Na? So 202, 204, 206 up to 288. Then 402, 408 up to 404 up to 488. Listing it out is not possible here. So manual counting is impractical here. That is why we are using fundamental principle of counting. Same question can be done with permutation combination, but that will be more confusing. So I am fixing this fundamental principle of counting for most of the questions in this chapter or in this previous year questions. Most of the question can be done with fundamental principle of counting. All of you understood this? Yes, learner, exactly. So you can comment whether you have understood or not. I'm trying to explain it as simply as possible. So try this question, GATE 2015 question. This kind of question was asked in 2 different GATE exams. Make a try, all of you. Okay, many of you got it right. Wonderful. 5 teams have to compete in a league with every team playing every other team's exactly what? So kind of a round robin kind of tournament. Before going to the next round, how many matches will have to be held to complete the league round of matches? So 5 teams I will call A, B, C, D, E. So this question, either fundamental principle of counting or basic counting, both way you can do it. A will play how many matches? A should play with all these 4 people. Now yesterday we discussed this idea already. So 4 matches A should play. B should play 4 match, but already A's match with B is B's match with A. Na? The order does not matter here. When order does not matter, that is when you have to use combination. Only selection, arrangement is not needed. Yeah, combination way we will discuss after this. So B only have to play 3 more matches with the remaining 3 more people. With only remaining 3 people, B should play a match. Because A's match with B is same as B's match with A. They are not different. AB same as BA. Because everyone will play exactly once only. And A's match with C, B's match with C is already counted in these 2 numbers. So definitely C will play only with the remaining 2 people or 2 teams. That is 2 matches. And D will play only with E because all other matches are counted. E should not play any more match because everyone have came to E's. Think that it is a cricket tournament where the country of E is where the match is conducted. That is why everyone is coming to that country and playing the match. Just for imagination I am saying. Now total number of matches. A's match plus B's match plus C's match plus D's match plus E match. That is 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4, that is 10. This is one way of doing it. But in this question, combination way is even more better because that is faster. I told you combination. I actually, what I will suggest all of you is permutation. If you completely forget, it is okay. Combination, try to remember because combination, if you try to remember both, unless you are good at that topic, unless you are clear about it, you can get confused. Tomorrow I will make it clear for you with further explanation. But for the time's sake, only think about combination. When we should use combination, when you are only concerned about selecting things, not worried about the arrangement. Like selecting A and B. AB and BA, if it is different, you cannot use combination, you should use permutation. But here AB and BA are same now. So AB match only we are worried about. A's match to B, B's match to A are not different. That is when only selection matters. Only selection matters. If only selection matters means from 5 teams, you have to select 2 teams and make them play. So how many ways you can do that? 5C2 ways are there. 5C2, those of you don't know how to find. Yeah, 5C2 is 5 factorial by 5 minus 2 factorial into 2 factorial. or NCR is n factorial by n minus r factorial into r factorial, or what is a shortcut way of doing it? 5C2, 5 into 4 divided by 1 into 2. In school days you used to do this now, and all of you are already familiar. I'm just assuming if 2 is in the bottom, 2 numbers in decreasing order and 2 numbers from 1, because the rest of the numbers will get cancelled anyway. So anyway, that is 10 itself. So this is a combination way, this is a logical way of doing it. Otherwise, yeah, this is a normal counting way. If you use the fundamental theorem of counting, that way also you can do. How? Just generally think, 5 teams, everyone will play with 4 people, 4 teams each. So 5 into 4 ways will be there. But among them, half of them are repetition, because A's match with B, B's match with A, both are counted in this 5 into 4. So only half of it can be taken. That way also you can do this 10. Now I think all of you are getting an idea how these methods are connected. Did you all understood? This is the, whichever way you prefer, you can do that way. If you are good with combination, do this way. If you are not good with combination, this will be better or this will be better. Hope this is clear to all of you. These kinds of many questions can be asked. I'll just give you one more question where this ideas can be used. So can you try this question? This is a question asked in a previous CSIR question paper itself. Make a try, all of you. Not a GATE PYQ, but for practice this is very useful. So please try. Yes, Manish. Learner, I will show you questions where at least is coming there, then you will understand. Actually, there are many variations for the same question. About that, we will discuss in the upcoming questions. So, many of you already got it right. From 11 persons, you want to know how many handshakes are possible. For handshakes, how many people are needed? For playing a match, two teams are needed, na? Or 2 things should be selected from 5 things. In the previous question we learned. Here also for handshake also, you need 2 people at a time, na? Because 2 people will handshake. 1 person cannot handshake like this. 3 people will not come together for a single handshake. So definitely 2 people at a time we need to take. If you need to select R things from N things, you can use combination. So if you are good with combination, you need to select 2 people from 11 people and make them handshake. So how many ways are there? 11C2 ways are there. 11C2 is 11 into 10 by 1 into 2. This is a combination way of doing it. Otherwise, you can just think if A, B, C, D up to K, they are the 11 people. A will handshake with 10 people except A will handshake everyone else. B will handshake 10 people, but already 1 handshake of A is counted in this list. So remaining 9 people only we should handshake again. C will handshake only remaining 8 people, just like the previous question. And D will handshake 7 people up to finally K will handshake 0 people. So number of handshakes will be 1 plus 0 plus 1 plus 2 plus 3 plus up to 10. That is 1 plus 2 plus 3 plus up to 10. Sum of first 10 natural number. 10 into 11 by 2 it is. That is also 55. That way also you can do it. Otherwise you can generalize like this. Fundamental principle of counting. 11 people, 10 ways they can handshake with each other. But half of them are only original. Remaining are duplicates. Because A to B handshake, B to A handshake are the same. So 11 into 10 is A to B handshake, B to A handshake, different case, permutation case. But only half of it is true because the remaining are duplicates. That way also you can do. Again, don't get confused about all 3 methods. Just take which is relevant for you, which is faster for you. Hope this is clear to all of you. Okay, coming back to another question asked in GATE 2012, where teams and number of matches itself is asked. But see how it is different from the previous question and then answer. All of you. Okay, many of you got it right. Wonderful. 10 teams participate in a tournament. Every team plays each of the other team twice. From the previous question understanding, we can extend. If they were playing once, every team playing once, 10C2 ways would have been there, na? Because from 10 teams, you need to select 2 teams. How many ways that can be done? 10C2. But as they are playing twice, you can say 2 times 10C2. Actually, this question is connecting combinations with permutation. 2 factorial n r factorial times ncr is going to be p factorial, sorry, npr itself. So anyway, 2 times 10c2, that way you can do it. 10c2 is what? 10 into 9 by 1 into 2. 2 times that will be 90. Or you can just think in the same way previous question. A will play in the first round, like in IPL. You can think about the league stage of IPL. Think about the first round. A will play 9 match, B will play 8 match, C will play 7 match up to K will play, J will play 0 match. Total adding you will get 45. That is one time. That is one round. One more round means 45 plus 45, 90. That way also you can do the question. Hope that is clear. Whichever way, or 2 times 10c2 is directly 10p2. If you are familiar with what is 10p2, that way also you can do. I'm not mixing it up because I don't want to confuse you now. Tomorrow we will discuss more about the connection between combinations and permutations. So anyway, if that is clear, yes, Sonia, permutation can be used. Totally correct. So let us go to the next question then. All these are previous GATE exam question. So make a try with this question, GATE 2018. So straightforward a question. Yes, learner, you can interpret that way also. Every team will play 9 matches individually. A's match with B, then B's match with A should be separately counted. So A play 9 match, like home match away match concept in IPL. Yeah, before COVID times, the home match away match concept was there in IPL. Na? Every team will play in their home ground also, away ground also. So every team will play home match also, away match also, means every team will play 9 matches separately. That way also you can do. Very good. Many of you already got it right. 3-member committee has to be formed from a group of 9 people. Yeah, if the combination concept is clear, from 9 things you need to select 3 things without worrying about their order. Only selection is needed. Only selection means combination. Selection and arrangement means permutation. So 9C3 is the answer. 9C3, how to solve it? 9 into 8 into 7. 3 numbers you write. And 1 into 2 into 3. In case if anyone have confusion how to write it in shortcut way, I just explain. So anyway, 2 into 3, this will cancel with 4, and 3 and 9 cancel with 3. 3 into 4 into 7 is going to be the answer. That is 84. Here, the order does not matter because yesterday also we have discussed the examples of that. The 3-member committee you are forming, ABC, BCA, CAB are not different. All are same. The different committee members have no different positions. Yesterday we discussed that general manager, manager, assistant manager case. There the order was important. ABC, BCA, CAB all are different. But here all the 3 people in the committee have the equal positions itself as mentioned in the question. So 9C3 is enough. 84 is the answer. Then can you try this question? GATE 2020 problem. All of you make a try. Yes, Takesh, very true. Yeah, this is a little different from the previous question. So carefully read it and then answer. Okay, so I'll explain. So if PQRS have 4 individuals, how many teams of size exceeding 1? Yeah, some of you were asking at least 1 comes, what happens? In all the previous question, it was clearly mentioning what is the size, if it is 2 or if it is 3. But here it is size exceeding 1 means there are different possibility. That is, size exceeding 1 means 2 people team is okay, 3 people team is okay, 4 people team also is okay. Total 4 people only are there. And in every team, Q is a permanent member. Q is there for sure. Q plus 1. This is Q plus 2 and this is Q plus 3 people. Are you all understanding? Because Q is a member in all the type of teams. So this is a scenario. Did you all understand? So you can do this question with combination, but that is unnecessary, that is time consuming. I will tell you the shortcut way of doing this question, or in general for bigger cases also the shortcut method will be much effective. So Q is a permanent member, so don't worry about Q. Only worry about the remaining people, P, R and S. So exceeding one team means, as already Q is a permanent member, exceeding one means other than Q, at least one more person should be there. At least one more person, because one se bhi zyada hona chahiye number of team members. So at least one person from P, R, S should be there in the team. At least one person means one person, two person, three person, all the cases are there. So let us think about the choices P, R and S have. Think that we are asking to P, R and S about this, whether they want to be part of the team or not. Let us try to understand. That way, practically think. You are actually the team manager and you are asking P, do you want to be part of the team? So P have two choices, either to say yes to the proposal or to say no to the proposal. P either says, yeah, I want to be part of the team, or says, no, I don't want to be part of the team. That means two choices P can make. And R can make how many choices? Same way, two choices, yes or no, two choices now. And S also can make yes or no, two choices. And for each of P's choice, there is two choice for R, two choice for S also. So fundamental principle of counting, 2 into 2 into 2, 8 choices. But in this 8 choices means what? P saying yes, Q saying yes, sorry, not Q, R saying yes, P, R, S. R saying yes, S saying yes. Yes, yes, no. Yes, no, yes. No, yes, yes. Or yes, no, no. No, yes, yes. No, sorry. No, yes, no. No, no, yes. And finally, no, no, no. But is this an acceptable choice? These are the 8 choices. Is this an acceptable choice? All the 3 people saying we don't want to be part of the team, or we are not part of the team. That is not acceptable according to the condition, because then Q only will be in the team. That is not exceeding one size team. That is why from the 8 choice, you need to subtract one choice. That is 7 choice only are remaining. You don't have to list it like this. This is I'm teaching you what is the concept. Once you understood that concept, 2 raised to n minus 1 will be the answer. For this question, you may be thinking why we need to think this way. This will be relevant, more relevant when you see if the team size is bigger. Instead of 4 individuals, if there is 10 individuals also, this will work. Are you understanding? So I will give you an extra question. If instead of 4 individuals, P, Q, R, S, T, U, V, if there are 7 individuals, all the rest are same. All the rest of the question is same. So if there is 7 individuals, what will happen? Can you all try? Q should be a member and exceeding one size. Mention the answer in the chat. I'm not rewriting the options. You can mention the answer in the chat. Yes, Sonia, this will save time. So this was a GATE 2020 problem. So we will just generalize this also, so that any kind of question like this comes, you can do it super easy. Okay, many of you got it. Some of you got 63, some of you got 64, some of you got 127. Let's see which is correct. Yeah, Q is a permanent member, just like previous question. Q is fixed. So there are only 6 people that can change. That is P, R, S, T, U, V. So P, R, S, T, U, V. So exceeding one means At least one person should be there from P, R, S, S, T, U, V. So P have two choices, R have two choices, S have two choices, T have two choices, U have two choices, V have two choices. Total choices will be 2 into 2 into 2 into 2. That is 2 raised to 6 choice. But in that 2 raised to 6 choice, when all the 5 people say no to your idea of making a team, that is not acceptable. So 2 raised to 6 minus 1, 2 raised to 6 going to be 64, 64 minus 1, 63 is the answer. Is this clear to all of you? Is this clear to all of you? So in this kind of a seating arrangement problem or in a team selection question like this, it can come, or the question can be asked in a totally different way also. I will show you an example. What if this comes? Exactly, Sonia. That salad problem also was the same. What if this comes? This is a practice question. All of you do it. This also is the same, na? Coin toss 5 times. How many different ways are possible where there is at least one head? कम से कम एक हेड होने चाहिए. मतलब 1 head चलेगा, 2 head चलेगा, 3 head चलेगा, 4 head चलेगा, 5 head भी चलेगा. 0 head नहीं चलेगा. So if you think from each of the tosses, what are the 2 choices it have? Head or tail are the 2 choices. Like in the previous question, the choice was to be part of the team or not to be part of the team. Here the choices are to get head or tail. So 2 choices for 5 times only. So 2 into 2 into 2 into 2 into 2, 2 raised to 5 choice. But the choice when you get all the 5 tail, that is not acceptable, na? So 2 raised to 5 minus 1 again. That is 32 minus 1, 31 would be the answer. Why you need to subtract that one? Because all 5 being tail is not okay, because kam se kam ek head milna chahiye, na? Then what about 1 second. What about this question? Can you mention the answer in the chat? Any answers? Let me check the chat. Very good. Many of you got it right. Here actually you don't need to subtract that 1. That is why I have asked this question. In the previous questions we subtracted that 1 because there all it was asking at least 1. At least 1 person should be there other than Q in that team question asked in GATE. In the previous question, at least 1 head. But here, all the 5 being false, all the 5 being true is also okay. 5 questions, you can answer it in 2 ways each question. True or false, true or false, true or false, true or false, true or false. So definitely 2 into 2 into 2 into 2, 2 raised to 5, 32 will be the answer. What I am saying is don't just by heart always 2 raised to n minus 1. According to the scenario only you can decide. So here it is 2 raised to n only. Yeah, this is actually school math only. Relations and functions you are learning. Power set concept, that only. But the logic behind that power set concept, that is what we are using to find the answer. So hope this is clear to all of you. So according to the scenario, you should make your strategy and do it. So then, second. Try this question also. And then this is 64, not 6, 64. All of you try this question and post your answer in the chat. New students, tomorrow 11 a.m. there will be a verbal ability class in my Unacademy profile. You can check in the community tab of this channel itself to get the details of that verbal ability free course. It's a free course discussing 100 previous year questions of GATE verbal ability. Tomorrow 11 a.m. will be the live class timing. You can attend it for free using the UnlockCode CC10. You can access the free class, and there are more than 400 free classes I have given in my profile. In the CSIR-UGC NET category I am teaching, that is why my GATE classes are also available in the CSIR-UGC NET category of Unacademy. Day after tomorrow, day after tomorrow 11 a.m. there will be a YouTube live in the Unacademy free platform. So if you don't want to miss any of my free classes in this channel or other channels or Unacademy platform, you can just be part of my Telegram channel and Telegram group. The details are given in the bottom of the screen and also in the description of this video. And also you can follow this page, subscribe this channel. In the community tab also I update regularly whenever I take a free class. Or you can just download my mobile application. Through my mobile application also you will be getting notifications of all my free classes. So very good, many of you already got the answer right. For a student to pass in an examination, it is necessary for him to obtain minimum marks in each out of 6 subjects. या एक सेमेस्टर एक कोर्स में पास होने के लिए हर सब्जेक्ट पास होना चाहिए ना. वन सब्जेक्ट फेल हुआ तो भी कोर्स फेल हुआ. So same thing here also, all the 6 subjects he should pass. So how many ways he can be failed? So the only way he can be passed is all the 6 subjects passing. All other ways are ways of failing. All other ways are means each subject, think from the perspective of each subject. फर्स्ट सब्जेक्ट के पर्सपेक्टिव में क्या क्या पॉसिबल है, पास हो सकता है या फेल हो सकता है. या वी ऑलवेज से ना, डोंट वरी अबाउट एग्जाम, आइदर यू विल पास और फेल. सो नथिंग एल्स कैन हैपन ना. सेम वे वी कैन से either pass the exam or fail the exam. Two possibility for all the 6 subjects. So 2 into 2 into 2 into 2 into 2, 64 possibility or 2 raised to 6 possibility. But this possibility is also included in this ना. pass possibility also included है. इसलिए वो case subtract करना है. That is 63 will be the answer. So here subtract karna tha because all getting passed is not a way of failing. For failing, at least one subject should be failed. So 0 subject fail case subtract करना है. ये जैसा क्वेश्चन कॉम्बिनेशन से करना है तो कर सकता है. एक सब्जेक्ट फेल करने का तरीका 6C1 है, दो सब्जेक्ट फेल करने का तरीका 6C2, 3 सब्जेक्ट फेलिंग 6C3, 6C4, 6C5, 66. Adding all these up also, believe me, you will get 63. But why waste all those steps and time? Don't do that. That is why I told you, when combination is needed, use that. Otherwise, fundamental principle of counting is much stronger or much generalized form rather than combination permutation formula. So let us go back to one more PYQ. So try this question. Super easy question, GATE 2020 problem. Yes, you can express it well. Ashutosh, tomorrow also we'll be discussing permutation combination. The last lecture on permutation combination will be tomorrow. Like to know your opinion about this course, how this course is going for all of you. Is this good for all of you? Are you understanding the concepts? You can mention in the chat. And also after the video or live is finished, if you are watching it as recording, please comment what you felt about this course. Positive or negative you can mention, so that others also will be able to know about the course and more people can attend also. If this is beneficial for more and more people, that will definitely help this channel also to grow. So make an effort to spread the word about this course. Share it with all of your friends, share it in your WhatsApp, Telegram groups, and also comment and like and subscribe. That will be very helpful. This is an initiative I'm taking after almost 2 years, because last 2-3 years almost all my classes were in the Unacademy profile only, but I am now thinking about giving classes through my channel also regularly. So it will help a lot if you people are spreading the word and inviting more and more people to this free classes daily. And thank you all of you for the good words. Zion, Wasfa, Learner, all of you, thank you for the good words. Ashwini also, Maya also, thank you all of you. So this question is super easy, super simple now. PQRS are to be uniquely coded, only using alpha beta. So alpha beta, there are only 4 ways you can rearrange it now. Alpha beta, beta alpha, or if in the order alpha itself you start alpha alpha, beta alpha, beta beta. These are the only 4 ways. And question says already alpha beta taken. Alpha beta taken. So uniquely code करने के लिए सिर्फ only 2 things are remaining na. Only 2 things are remaining. So alpha done, alpha beta done. So only 2 things are beta alpha, beta beta. Beta alpha, beta beta is only in option D. So they should be R and S. What is the order you listed is not necessary. Options will help you to do it faster. So super easy question asked in GATE 2020. This is why I'm saying this chapter, very simple questions, little complicated questions, all were asked. So can you try this number based question? All these are, you can see that almost all the questions we discussed today, previous year questions, we can do it directly without any much learning. Basic understanding of fundamental principle of counting was enough. So try it. Thank you Manish, thank you Pratusha, thank you Sonia, thank you for the good words. Thank you Learner. Thank you Mamta. So we'll try to continue this course till your GATE exam. Whenever is your GATE exam being postponed, I'm still trying to continue this course till that date, so that you will be getting help from me till your GATE exam. So Monday to Friday at least, or some days, some Saturday, Sunday, if I'm getting free, we will take classes on Saturday, Sunday also. Let us wait for this official notification to come, whether the exam of GATE is postponed, will be postponed or not. Right now there is no information till now. If it is getting postponed, maybe we will try to continue the series elaborately. That is why I'm trying to take more lectures on permutation combination and topics like that, which is little tough for students, hoping that maybe we may get few extra days if the exam is getting postponed. Hopefully exam should not get postponed, because getting postponed, it will be again delayed. And so anyway, we'll just hope for the best. If exam does not postpone, we will try to continue this session for next 15-20 days. If it gets postponed, we'll continue it till your GATE exam itself. Thank you, Ajay. Okay. So many of you got it right. So GATE exam sometimes give numerical answer type question, NAT. Very rarely nowadays you see NAT, where you have to enter the answer in the screen. So this question is like that, options are not given. So nowadays in aptitude section, you see NAT very rarely. 2021 NAT was not there, but NAT or multiple choice, this logic you can learn from this. How many 4-digit numbers can be found with 10 digits? 0, 1, 2, 3, 4 up to 9. If no number can start with 0, yeah, 4-digit number, no number start with 0. So that is a constraint. So this part is where we have a constraint. So we will start with that itself. We will start with that itself. Yeah, some of you ask me when repetition comes, if repetition is not allowed, what will happen? With this question, you will understand it. That is why I didn't discuss that time, because we are already going to discuss. So anyway, this position. So in these kinds of questions, when repetition is not allowed, you should be careful. You should start with the position where the constraint is there. The position where the constraint is there is the leftmost position, or we can say, yeah, for example, if the number is 1, 3, 1, 2, 3, 4, ये होगा thousands place, ये होगा hundreds place, ये होगा tens place, ये होगा thousands place, sorry, units place. So thousands place 0 नहीं हो सकता. So thousands place क्या क्या हो सकता है? 9 possibilities are there, ना? Except 0, all other 9 digits are possible. Except 0, all other 9 digits are possible. Now, hundreds place 0 is possible, but the number used here, whichever is the number used here, just like the anagram problem we discussed yesterday, just the number you used here, whatever it is, that cannot be used. All the rest 8 numbers plus 0 is possible. 0 and all remaining 8 numbers, that means 9 numbers are still possible, na? 9 digits. For example, if you fixed 1 here, second position can be filled with 0 also, 2 also, 3 also, 4 also, 5 also, 6 also, 7 also, 8 also, 9 also. That is 9 numbers are still remaining because 0 extra we got. Now here 8 numbers only, because 2 numbers you already used here. So 10 minus 2, 8 numbers only. Here 7 numbers. Numbers means digits. That is what I am meaning. So again, fundamental principle of counting, 9 into 9 into 8 into 7. I will give you some practice questions of this type for your further understanding of this topic. Did you all understood this much? So 9 into 9 into 8 into 7 will be the answer. 9 into 9 into 8 into 7 will come up to 4,536, right? 4,536, as in GATE exam calculator is allowed. You can directly use calculator and do it. Yeah, start practicing with calculator. If you are preparing for GATE, start practicing using online calculators, or get a model of the online calculator you get in GATE exam. You can search online, you can get it, the virtual calculator you see for GATE exam. For other competitive exam like CSIR and other exams, calculators are not allowed. In that case, you have to use Vedic maths, or you have to practice Vedic math. My Vedic math classes are also available in this channel as recordings. So basic Vedic math tricks I have taught in that series. And there are other educators lectures which are included in this channel. Some other educators who are my students and friends who have taken classes, their videos also you can check out in this channel for learning Vedic maths, for learning CSIR-NET General Aptitude, for learning other competitive exams. Even NCRT based content also is added in this channel. Check it out, those of you are interested. So anyway, 4536 will be the answer. Yeah. So if, yeah, that is a good, yes, Sonia, you are right. If repetition were allowed, the first number you can say 9 ways only, but all other numbers could be filled in 10 ways if repetition was allowed. So 9,000 would have been the answer. So anyway, we'll go to the next question. This question is clear to all of you, I guess. Then try this question, GATE 2021 problem. In 2021, most of the questions were like this, where numbers are not to be fixed. People are need to be fixed in positions. That is seating arrangement type permutation combination or arrangement problem. So make a try. Here actually, if the options are small, manual counting is also okay. But if options are big, manual counting is not needed or not advisable because it takes time. Here actually, you can use, or yeah, it is better not to use manual counting. Use fundamental principle of counting itself. Start from the position where we have a restriction. Learner, this was a 1 mark question. Yeah, actually in 3 set, this kind of question was there. I forgot it is 1 mark or 2 mark. I will check it and let you know, learner. Just a minute. I have that question paper printout. Just a minute. I will check. Yeah, this was one more question only. This was one more question. Very good. Some of you already got it right. Wonderful, wonderful. Thank you, Amrita, for the good words. Okay, so I'll start explaining, or do you need more time? Yeah, complete trying. Let more answers come in the chat. Just like the previous question, you can start it. In the previous question, the constraint was you cannot fill the leftmost position with 0. Here the constraint is the second leftmost position cannot be filled with the person R. So this is the position where we have a constraint. So start with that position. That will be super easy then. So this position can be filled only in 3 ways. Which 3 ways? Either P से fill कर सकता है या Q से fill कर सकता है या S से fill कर सकता है. 3 ways. Now think about any other ways, any other positions, because all other positions are free to fill with people. The person who is sitting here cannot be sitting anywhere else because he or she should move at a velocity of light for that to happen. Just kidding. So anyway, if a person is sitting here, definitely if you think about the leftmost position, first position from the left, that can be filled with either R or the remaining person who is not sitting here. Among PQS, if P is sitting here, Q or S can come here, or any 2 of the remaining people. So there are R and 2 more people. So there are 3 ways of filling this now. 3 ways of filling this. Now fix one person fixed here, one person fixed here. So 2 more ways to fill this position because 2 people are already occupied. And 1 way to fill this. So total ways will be, again, fundamental principle of counting. 3 into 3 into 2, 18 is the answer. Yeah, seating arrangement problem. Many of the seating arrangement problem need this fundamental principle of counting. Some seating arrangement, actually circular arrangement, there are other arrangement question where this is not the idea. That we will discuss in seating arrangement chapter. But where permutation combination or this fundamental principle of counting, that kind of question we will discuss in this chapter itself. Hope all of you understood this. Then let's go to the next question. Okay, try this. 1 second. Yeah, try this itself. Little more complicated version of the previous question. Okay, it's already 7:17. So I think we will continue this discussion tomorrow. Anyway, one more session on permutation combination. So you can enroll for it now itself in the playlist. It is available. You can click on the notify me option. And yeah, you can mention the answer for this question in the comments also, in the chat also. Hope today's session was useful for all of you. We discussed almost 10 questions from previous year questions and almost 5 questions from practice questions. I will give you a few homework questions also. So please try this as homework also, and try this also. Try this also. We will discuss this tomorrow. And more number based question. All these questions we will discuss tomorrow. The PYQs we will try to cover all of them so that you get a proper understanding. This is a wonderful question. It's a wonderful question where that yes no idea can be extended here with the complement idea. Make a try. This also please try. All these questions, yeah, you can screenshot it after posting the video later. or yeah, actually I could not update in the mobile application till now the study material for this. That will be updated. All the questions that I'm showing in the class, I will update you in the upcoming days. So please try the pending questions also. So Manish, actually I haven't noted down the options for each of it. I also have to solve it. So I may also have to look into the question and find the answer and tell. So tomorrow we will discuss, Manish. So anyway, try this. Tomorrow we'll discuss all the doubts you have. And tomorrow we will conclude this chapter, permutation combination, and some more theory to be taught tomorrow. So if you like this session, please take your time to hit the like button. That is a second maybe. So yeah, so see you all in the next class, and tomorrow 11 a.m. rapid fire session for GATE verbal ability, where we discuss 20 questions will be there in the Unacademy free platform. My name you can search in the Unacademy free platform and attend that session, or you can be part of my Telegram channel and Telegram group. There I update all my upcoming classes. Or the easy way is you can download my mobile application. There also you will get updates. So one of the medium, if you are in touch, definitely you will be getting update from me. So that's it. I think we can conclude for today. So invite your friends also to tomorrow's class. And day after tomorrow, we will start the next topic after permutation combination. Thank you all for attending this session. Take care all of you. Have a good night. Bye-bye.